Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 32 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we are using the Sunfounder Raphael Raspberry Pi kit. Most of you guys probably already have your gear. If you don't, look down in the description. There is a link over to Amazon where you can pick this kit up. And believe me, your life and my life are going to be much easier if we are working on identical hardware. Sunfounder, putting the tech back in TopTechBoy.com. But enough of this shameless advertising. Let's talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in which I gave you in lesson number 31. And in lesson number 31, I showed you guys kind of how the keypad works, and I sort of showed you how you could read an individual button. And then what your assignment was to go in and take what I had taught and start putting together something that would be a little more useful, something that would behave like this, where if I run the program and I come over, if I press the 4, I get a 4, a 5, whatever key I press, it tells me the label of that key. Also, very importantly, if you hold it down, it doesn't repeat. But if you come back later, you can enter the same number twice. How many of you guys were successful with the homework? If you were successful, leave a comment down below. I am uber legend, double chest bump, and otherwise I fold it up like a cheap Walmart lawn chair, or I fear the worst possibility is I never even entered the arena. Now guys, this should be fairly straightforward based on what I taught you in lesson number 31. Okay, but it was a little bit like that old classic toggle switch problem. You really had to think about it. But let me jump in and kind of sketch things out about how this thing works. And this is a little bit of a review of some stuff that we talked about, this stuff we talked about last week, but I just want to review it before I jump in and start coding. And so how does that keypad work? Well, what you got to see is the keypad has 4 rows. Okay, so I've got 1, 2, 3, 4 rows, and then I have 4 columns. 1, 2, 3, 4. And then the device itself has 8 leads. 1 lead for each row and 1 lead for each column. So we are going to read from 16 switches based on 8 connectors. Now, how does that work? Well, you have to think of this as row, that's not good. Let me keep my color straight here. You got to think of this as row 0, row 1, row 2, and row 3. And then you have to think of these as column 0, column 1, column 2, and column 3. Okay, and then there are switches at each one of these intersections. You have switches between each intersection. I will go through this as quick as I can because I know this is review. But each one of these intersections, you have a switch. This is passive. It is nothing but wires and switches. There is no electronics or no fancy business in here. It's just wires and switches. And so you've got a switch at each one of the intersections. So these rows, the rows are going to be connected to output GPIO pins. Okay, the rows are connected to output GPIO pins, and then the columns are connected to inputs. So we're going to have how many outputs? 4 output pins. We're going to have how many inputs? 4 input pins. And when we set up our input pins, we are going to set them up with what? Internal pull down resistors. Internal pull down resistors. How do we do that? We do that with the pin setups when we set up the GPIO pins. I have 4 inputs, I have 4 outputs, and that gives me a total of 8 pins. How do I read a specific switch? If I want to read this specific switch, I will take R2 and I will select that row by taking that output pin high. And then what I will do is I will then read from column 2. So I set row 2 high, I read from column 2, and then I set the row 2 low. So I select it by setting it high, I read from the column, and then over on the row, I then set it low. And so therefore, I can read any one of these that I want to. Okay, so now how do we get that really slick behavior that I was showing you? How do we code that up where I can read each one of the buttons as I press it? Well, let's go through and let's think about it a little bit. Let's come back over here to our code view. Give me just a second here to get this all straightened out. Okay, I think we're ready to go here. And I'll come over here where I see it. All right, so let me go ahead and just kind of get the pin set up, and then we'll talk a little bit more about how the program is gonna work. But we're gonna need to come in, and we're gonna need to import rp_i.gpio as GPIO, then from time import sleep, and then we need to do a GPIO.set mode, and that is going to be GPIO.board configuration. Okay, so we've got it set up as a board. And now we got to figure out what are our input pins and what are our output pins. Well, if I look here and I look at the physical pins here on the left and you go up, you can see that I've got 8 pins coming down here that I can use, starting with 11. I can use GPIO 11, 13, 15, and then 29. I can use those first 4 as inputs, and then I can use 31, 33, 35, 37 as outputs. And so let me just sketch that up just to make sure that we are doing this the same way. And so I will come over here, and we are going to have a row 0, row 1, row 2, and row 3. And then we're going to have column 0, column 1, column 2, and column 3, and we're just going to kind of go down that left set of pins. And this was 11, this was 13, this was 15, and then the next one we could use was 29. And now we're coming into the columns, and we could use 31, 33, 35, and 37, like that. All right, and now when we do that, what we end up with is we end up just sort of coming down here, because remember, this is row 0, row 1, row 2, row 3, and then column 0, column 1, column 2, column 3. We just kind of, that top row of pins, we just come down and hook them up in the same order. And I like to use this ribbon cable so that it makes it a little easier to get to get things set up. So okay, that's enough of telling you how I'm going to do it. Now, I showed you last week how it's a little bit easier to keep track of our pins if we make matrices. And so I'm going to make a matrix for the row pin. So I'm going to say my rows are going to be equal to, that was what? Look back at the little chart. It was pin 11. It was pin 13, it was pin 17, and then pin 11, 13, 15, and then pin 29, like that. Close the row. Then my column pins, my columns, those were 31, and then 33, and then 35, and then 37. Okay, so I've got a matrix for my row pins and a matrix for my column pins. Now I'm going to go ahead and set up the keypad label. So I'm going to call that keypad. And this is just going to put the labels in as a, that's not a very good view, the labels in as a function of rows and columns. So my labels would be like 1, 2, 3A, 4, 5, 6B, like that. So I'm going to set that up over here. And so what I will have is I will open the matrix. Now I open the first row. So I have two opens. Open the matrix, open the first row. Then I have the integer label 1, 2, 3, and then the character what? A, right? I'm just reading across here. First row is 1, 2, 3, A, like that. Now we'll come back over here. And then I need to close the string on the A. Now I close the first row. Now I put a comma. I open the next row. And then what do I have? I have 2. I have 4, 5, 6, and then the character B. And make sure you put the little quotes around the B. I close that row. I put a comma. I open my next row. What is there? The integer 7, 8, 9, and then the character C, like that. Okay, and now I put a comma. Now I open my last row, which is the character asterisk, and then the integer 0, and then the character pound, and then the character D, like that. Close the row, close the matrix. Close the row, close the matrix. Okay, now I'm going to run that just to make sure I don't have some silly mistake in here. I run it and it is happy. Okay, now I need to set up my GPIO pins. Let's set up the input pins. Let's set up the input pins, GPIO dot set up, and the input pins were the what? They were the rows, and so it is going to be rows, the 0. And so what is row 0? Row 0 is pin 11. And then what do I want that? I want that to be a GPIO.out, like that. I'll close that. Now the next 3 will be almost the same, so I will copy, Control C, Control V, Control V, Control V. That was rows 0. This is rows 1, rows 2, and rows 3. So now I have my row pins configured as outputs. Now I need to configure my column pins, and so this is going to be GPIO.setup, and then what? Columns, the 0th column, and that is what? That is a GPIO.in, and don't forget what? You've got to activate the pull down resistor, so I say pull underscore up underscore down, okay, and that's equal to GPIO dot pull up down underscore down. Let's run this just to make sure before I copy and paste all that. I'm getting more and more where I like to run the code as I go, just so I can kind of get rid of my errors as we're going. That's going to be column 1, column 2, and column 3. Come in and make those adjustments. This is column 1, column 2, column 3. If I'm going too fast, go back and look at last week's lesson because I went over all this last week. All right, now this is what we have to do now. We have to think about the way this program works. And I've got to step through all the whats. I've got to step through all the rows, and I've got to step through all the columns, and I have to read each one. So what do I have to do? I have to activate the first row and then read column, 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 then activate the next row, column, 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 then activate the next row, column, 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 column. Okay, and so I'm going to have to do 16 reads. So we'll come back over here. Let's go ahead and set up our try and accept, and then we'll start stepping through these things. So I'll say try. This will be the main part of the program, and then we'll have the accept out on keyboard interrupt. And then what are we going to do in the keyboard interrupt? I will wait about 0.2 of a second so it can finish whatever it's doing. Then we'll do a gpio.cleanup like that, and then I will do a print gpio good to go, good to go, like that. And now what am I going to do in the try? Well, this is where I'm going to go in and I'm going to need to read each one of those 16. I am going to need to read each one of those 16 buttons every time. So what will I do? I'll say while true. Okay, and what I'm going to do first is I'm not going to worry about the sticky finger where you hold it and then it just keeps reading that same number. Let's just go through it and then we'll come back and I'll show you how to fix the sticky finger. But I think it'll make more sense if I don't do that to begin with. So I'll start with a while true. When it's true, true. True is always true. And so I've created an infinite loop. Now I need to step through the buttons. How do I do that? I'm going to step through the rows and step through the columns. So how would I do that? Well, I will say for my row in, and then what do I want to step through? The rows. What are the rows? I have row 0, I have row 1, I have row 2, and I have row 3. Okay, so I'm going to step through the rows. Now for what? My column in, I have which columns? I have 0, 1, 2, 3. Those are my columns. So I'm stepping through the rows and I'm stepping through the columns. Now what do I need to do? I need to activate the row. So I'm going to say GPIO, and then I'm going to say output. And what am I going to want to output? I'm going to want to output the row. And so that would be rows of my row, rows of my row. And then what I'm going to do, GPIO.high, like that. Okay, now what do I want to do? GPIO, I need to do a read now. So I'm going to say the button value is going to be equal to GPIO.input, and I read from the what? I read from the column, and this should have been here. I messed up a little bit. Open parenthesis, and then here, that is a close parenthesis. And I'm going to read from not rows, but columns. And then which column? My column, like that. And then columns of my column. And then that is, I think, all I got to do there. Just close the read. And now I've got to put that row select down. So GPIO out, GPIO output, and the rows of my row needs to be now GPIO.low. Okay. That's just going to be a closed parenthesis like that. All right. Let's step through this. So we get here, and the first time through, what are we going to have? Well, row is going to be 0. Then we come down here, and column is going to be 0. So rows of my row is going to be rows of 0. and rows of 0 is going to be pin 11. So we're going to turn pin 11 high. That does what? It selects row 0. Then we come in, and what do? We are going to, this doesn't like something here. What did I do wrong? I got an error here. Getting my parentheses and squares mixed up, square brackets messed up. Okay, so I'm on row 0. I activate row 0, and now I'm going to read from columns of 0, and columns of 0 is going to be pin 31. So I bring pin 11 high. That activates the first row, and then I read from pin 31, which is going to be the first column. And so what am I doing? I am reading row 0, column 0, and that is this character. That is this character right here. I'm reading from this button. And then what am I doing? Now, after that, I am stepping through the columns. So I'm going to read this one, read this one, read this one, read this one. Then what happens? You increment the row. You read this, 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 and then you increment the row. And then you remember to activate the row, you bring it high, you do your read, then you bring it back down. So let's come back over here. And so that is what this does. So I activate the row, I read the column, and then I bring the row low. Activate the row, read the column, bring the row low. All right. Now what I need to do is, let's say that something was pressed. I can say if the button value equal 1, if the button value equal 1, then what do I do? If the button value equal 1, now I got to figure out what is the label there. My character, the character is going to be the label, which I get from this. I'll know what row I'm on, I'll know what column I'm on, so I have to find its label. And that's very easy because of the way that we've set it up. My character is just going to be keypad, okay, of my row, close the bracket, open the bracket, my column, like that, okay, because I'm stepping through my rows and I'm stepping through my columns, and then I get the label. My character is the label, and I get it from my keypad of the present row and the present column, like that. And now what I think I can do is I can print my character. All right. Now I do believe what I will need to do is I will need to go ahead and let's just do a sleep of, let's say point. I don't want to do the sleep there. I want to do it after I've gone all the way through. So here I'll do the sleep of 0.2, like that. All right, let's run this thing and see what happens. Okay, my GPIO pins were not released, so let's try it again. Okay, no errors so far, that's good. So let's come back over here, and remember I'm going to have the sticky button problem if I just do it this way, but let's just see at least if we're reading things. Okay, so if I come in and press D, hey, I get a D. But notice if I hold the D down, it's repeating. So if I was getting keyboard input and I wanted to put a 9, it's going to be accidentally reading multiple 9s. So you see, this is the sticky button problem that we've got to fix. But the good news is, look, like I can say 1, 2, 3, 4, or 1, 2, 3, A, 4, 5, 6, B, 7, 8, 9, C, star, 0, pound, D. Boom, look at that. So we're almost there, but now the tricky part. Now the tricky part. How do we get rid of that sticky business, And I'll tell you, I'll give you a hint. It is a lot like the old button toggle problem. And that is, if I have a 3 like I go through all the buttons and 3 is pressed. When I go back through the buttons, if 3 is still pressed, I don't want to take it unless it's gone through one time with nothing pressed. Okay, so I don't want to just put 3, 3, 3, 3. I only want to register the 3 if I have a what? If I have a no press condition. If I have a no press condition. And so I need a new variable. I need a new variable which is going to be no press. Okay, and what is no press? If I go all the way through, and nothing was pressed, then no press is true. I'm going through the buttons. If one of them was pressed, then no press becomes false because one of them was pressed. So what we're going to need is we're going to need two variables. We are going to need no press, and we're just going to start with no press equal to true. So no press is going to be equal to true because when we start, nothing has been pressed. Then just like we before had button state and button state old, we need what? No press, and we also need what? No press old. And since nothing's been pressed, it's not pressed this time, it's not pressed last time, no pressed old is also going to be equal to true. Okay, does that make sense? I hope that makes sense. Now let's come down and let's start thinking about how to use this variable that we've just set up of the no press and the no press old. Okay, let's think if button val equal 1. If button val equal 1, that means a button is pressed, and so what are we going to do? We're going to read it. Okay, we're going to read it. Well, we're reading it here already, but if the button is pressed, then what we're going to do is we're going to get my character, just like before. We're going to get my character, but we are not going to print it out. What we're going to do is, okay, if we get here, what does this mean? This means a button has been pressed. So no press equals false. So if we end up reading the character, like we read the number 5, what do we know? The button was pressed. So we drop a breadcrumb and we say no press is now false. Does that make sense? No press is false. So now this is the magic line. If but val equal 1, that means the button has just been pressed and no press equal false. What does that mean? That means you press the button and it got down into that if statement right before there, and no press old equal true. That means last time around there was no input. So this sort of releases the stickiness. You only end up down here if the last time around there wasn't a button pressed. Okay, does that make sense? What would we do here? In this case, what we would do is we would print my character. Okay, so you see what this is saying is you're always going to go out and you're always going to grab my character. Anytime the button is pressed, anytime any button is pressed, you're going to record it. But you're only going to report it if the button was pressed, okay, and the last time through the button wasn't pressed, okay? Because you don't want to just hold 7 and go 7, 7, 7, 7. You want to see that one time through it didn't read anything. So that means presently it's pressed, no press equal false, and last time through it wasn't pressed. And that keeps it from keep reading the 5 because it wouldn't get here this time because last time no press old was false. No press old was false. No press old was false. It won't keep reading that same 5 or it won't keep reporting that same 5. And then the only thing that we really need to do here is outside of that if statement, okay, outside of that if statement, what you are going to do is all the way back here, you're going to say no press old equal no press present, like that. Does that make sense? I think it makes sense before I put this in here. But you see, if I hold the button down and it reads 5, prints 5, reads 5, prints 5, reads 5, prints 5, that was just one button push. I only want to record it the first time that it reads it. So it needs to see before it reports it again, it needs to see that you took your finger off of it. How does it know that you took your finger off of it? The no press old is true, meaning that it read everything and nothing had been pressed. Now draw a picture of it. You're probably tired of me repeating it, but let's see if this thing is going to work now. So I run it. At least we didn't get any errors. Let's come back over here. And okay, it's looking good. So let's just see if I press D, I get D. That's good. Now let's press and hold D. Okay, and I've got a little bit of an error here because you see that it's sort of locked up. So let's see what happened here. So I've got an error. Okay, so the problem is that it will read one time and then it just locks up. And so you guys probably saw my mistake, but if I just run it and I press it, it locks up. So if we go back and look at the code view again, you can see that the reason it locks up is there's no way for no press to become true again. So when you start the loop again, you're starting fresh. When you start fresh, you have to reset no press to true. And so that would be right up here at the top. When you enter here, you have to say no press equal true, because as you're starting to work your way through the buttons, nothing has been pressed. And then no press only becomes 1 if you end up getting this button value that one of the buttons has been pressed. Now no press is false, okay? And so in order to report the character, you need to have a button pushed, and then last time through there was no buttons pushed. Does that make sense? I think it's going to work this time. So let's come over here. And then let's Control C, run the program, and we come over and we press D. That's good so far. And then I press 9. Good so far. Look at that. I'm not locked up now. Okay. 8. Okay, 5. Now let's check for the sticky finger. I'm going to press 4 and hold it, and I get 1, 4. Release it. Now, the real thing is, can I come in and press 4 again? And yeah, I've got it. So I could say 8, 5, 3, 3, 3, 6, 2. And you see I put the 3 3s in, but if I just come in and hold 3 down, if I just come in and hold 3 down, it is not sticky. All right, guys, we got this working. Did anybody figure out how to do this on their own? And even after watching me, you really have to understand, when we start, let me go back over there. When we start, no buttons have been pressed. If we go through and a button is pressed, then all of a sudden no press becomes false. Now next time through though, I don't want to reread the 5, and so you will not reread the 5. Why? Because no press old is false. You won't get in here. So you want the last time through no buttons pressed, and this time through a button pressed, and then you will record it. So that fixes the sticky finger problem. Wow, this has been a pretty darn fun lesson, and I hope you guys understand it. Did anybody do this? I hope somebody did this. All right, this is your assignment for next week. Your assignment for next week is to make this more useful. You can see right now I can enter one character at a time, but what I want is I want you to have a function. It's really best to do it with a function where when you call the function, it then returns what you entered. So let's say that you wanted like an access code, and like let's say your access code was 1 2 3 4 5. To enter that, you need to do 1 2 3 4 5, and then when you hit D, D is like the enter code. D is like enter. So you would put 1 2 3 4 5 and then D, and when you press D, it returns a string 1 2 3 4 5, or ABC. You can't use D now because D is enter, but you put in a sequence, and then when you hit D, it returns to your main program what that string is that you put. Does that make sense? So like if the code was 5 4 3 2 1, you would type in 5 4 3 2 1 in D, and then what it returns is it returns the string 5 4 3 2 1. Does that make sense? And I think at that point, if we have a function to do that, then we could start incorporating this into real projects. Guys, I hope you're having as much fun taking these lessons as I am making them. If you enjoyed the lesson, be sure to give us a thumbs up. If you want to help me with the old YouTube juice, leave a comment down below. That helps me with the old algorithms. And then share this with other people, because the world needs more people doing coding and engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.